So here we're going to use implicit differentiation to find the slope of the tangent at the given points to the curve here. And so this function, it's a crazy little function here, right? We have y cubed plus y squared minus 5y minus x squared equals -4. And so there's no way I could rewrite this so that it's in an explicit form y equals, right? It would just be too difficult to do. And so we're going to use our implicit differentiation. And so here are the 4 steps to doing it. The first, we're going to differentiate both sides with respect to x. And so we're going to have d dx of my left side, y cubed plus y squared minus 5y minus x squared equals d dx of -4. And so what's nice is this left or this right side is going to be 0. It's a constant. Derivative of a constant is always 0. When we differentiate the left side, though, every time we differentiate something with a y, we're going to differentiate it the way we know, but then we have to include a dy dx. And so when we do d dx of y cubed, we're going to use the power rule, and that will become 3y squared, right? There's the power rule of y cubed times dy dx. Plus, we're going to do the power rule with y squared, and so that's going to be 2y dy dx. Minus, we're going to take, again, use the power rule with -5y, and so that's going to give us -5 dy dx. Minus, now we're going to do the power rule with x squared, and because we're taking the derivative with respect to x, we don't need to include the dx over dx. That's just going to be 1, so we'll get minus 2x equals, and again, like we said before, d dx of a constant is 0. And so we have our derivative of 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x. Our next step is going to be collect all the terms with dy dx onto the left side and move all other terms to the right side. Well, everything here has a dy dx except for this -2x. And so we're going to get 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. And so now we're on step 3. We're going to factor the dy dx out of the left side of the equation. And so we're going to get dy dx equals, well, I'm left with 3y squared plus 2y minus 5 equals 2x. And now we're almost done. We're going to solve for dy dx. And so I'm going to use this color here. Dy dx is going to be 2x, and I'm going to divide by the factor on the left side that does not contain the dy dx, so that's 3y squared plus 2y minus 5. And so we'll get 2x over 3y squared plus 2y minus 5. And so that is the rule that will give me the slope of the tangent at any point on this graph of y cubed plus y squared minus 5y minus x squared equals -4. And so notice that implicit differentiation can produce an expression for dy dx that contains both x and y. There's no other way to write this other than having an x and a y here. And so now we can find the slope of the tangent at given points. And so if we look here, let's just pick one of these to do. So let's use 2, 0. And so at 2, 0, you guys can't see that. There we go. At 2, 0, dy dx is going to be equal, I'm going to plug in these values, 2, 0, so it's going to be 2 times 2, there's my x, over 3 times 0 squared plus 2 times 0 minus 5. And so the slope of the tangent at 2, 0 is 4 over 5, and that's going to be a negative. So that's the slope of the tangent at that point. If we wanted to write the equation of the tangent, right, using point slope form, we would have y equals negative 4/5 x minus 2. And so there's implicit differentiation for you. Again, we're using functions or graphs that are going to be difficult to do explicitly. We have to remember that when we take the derivative of y with respect to x, we're always going to get this dy dx term. We're going to get all the dy dx's to the left side, everything else to the right side, and so that's why we brought the 2x to this side. We're going to factor out the dy dx, and then we're going to divide by the term, the factor term on the left side that doesn't contain the dy dx to get the rule that will give us the slope of the tangent at any point on that curve. All right, hope that helped.